So I want to take a minute to just make a few more observations about these new formulas we have. So I just recopied them here at the top of the white sheet. Sine theta is y over r, cosine theta is x over r, tan theta is y over x. One is that for the rest of your lives, sine theta goes with y coordinates, and cosine theta goes with x. You got to get that straight. And you're never going to, I don't know, you're going to have to use that for a long time in all the rest of this course. That's going to help you out. We tend to say sine before cosine, but as we get to more advanced treatment of trig, often you'll see people saying cosine before sine because we tend to think of the x-coordinate before the y-coordinate. Also, as far as tangent is concerned, I just want to remind you that, tangent can always be thought of as sine over cosine. And I didn't give myself too much room here to write, but sine is y over r. Cosine is x over r. If you carry out that division, y over r divided by x over r, which is y over r times r over x, the r cancels out, and you're left with just y over x. So my feeling is you definitely gotta memorize these formulas for sine and cosine, but the tangent formula you could always rederive by just dividing the sine formula by the cosine formula if you don't want to memorize it as a separate. All right, now we've moved beyond SOHCAHTOA, and just want to make this observation again. When the terminal side of an angle falls in quadrants 2, 3, or 4, trig function values can be negative. And I want to draw a picture here. I'm thinking of this as a coordinate system. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So the quadrants are connected to where these trig functions turn out to be positive and negative, right? Because in quadrant 2, x is negative, right? But y is positive. In quadrant 3, both x and y are negative. In quadrant 4, y is negative, but x is not, right? X is positive. And it's almost like, I feel like you don't have to memorize this because you should already have a feel for where x and y are positive and negative and which quadrants they're positive and negative. But I just want to reiterate that. And some people do like to memorize these things. In quadrant 1, sine of an angle is always greater than 0, is always positive. Cosine of an angle is always positive. Tangent of an angle is always positive. The trig function values in quadrant 1 are always positive. In quadrant 2, sine will be positive because sine, I just said a moment ago, sine goes with y. R will not affect the positive or negativeness because r is always positive. The x and y coordinate do. Cosine in quadrant 2, though, is always negative because the cosine is the x-coordinate over the radius, and the x-coordinate's negative in quadrant 2. Tangent in quadrant 2 is always negative because it's a sine divided by cosine, a positive divided by a negative. So while all trig functions are positive in quadrant 1, in quadrant 2, of the three, sine, cosine, and tangent, only sine is positive. In quadrant 3, let's see, sine is going to be negative. Cosine is also going to be negative because x and y are both negative. But the tangent, turns out, because tangent is y divided by x, it's a negative divided by a negative will be positive. So tangent turns out to be positive while sine and cosine are negative in quadrant 3. In quadrant 4, sine theta, well, y is negative, so sine theta is negative. Cosine theta will be positive because the x-coordinates there are positive. And tangent of an angle with terminal side in quadrant 4, that will be negative again because sine divided by cosine again will come out to be negative. So of these three functions, only cosine is positive in quadrant 4. So some people like to memorize a little mnemonic. Again, I think you should just have a feel for where these are positive or negative because you know where x and y are positive and negative. But if this works for you, let me just tell you. So cosine positive, I'm just going to write a big C here. All, I'm going to write an A. Sine, I'm going to write a S. Tangent, I'm going to write a T. So sometimes people go around this way and think C-A-S-T to help them remember where the trig functions are positive and negative. You got to remember to start in quadrant 4 if you're going to use this cast thing and get that A for all in quadrant 1. And just one more observation I want to make, and this is maybe as we work on with these functions, we'll get more and more comfortable with where they're positive and negative. But I just want to say something about sine and cosine. You know, y-coordinates are positive above the x-axis, right? So in a coordinate system. So if angles have terminal sides anywhere above the x-axis, so all the way up here, so think of angles up here. Just sine theta is positive where y is positive, and that's in this upper half of the plane. Now, cosine's positive where x is positive. X is positive to the right of the y-axis. So over for terminal sides here, I would say, where can I squeeze this in? Cosine theta is positive where x is positive. So this is to the right of the y-axis, and the sine is positive above the x-axis. I don't know, those pictures help me a little bit. And that's it for this